Alright, welcome back. We're going to continue from where we left off. Sorry, the videos keep cutting out because they can only be so long. Okay, so let's talk about how it is that we know we're looking at a parabola by talking about its key features. So how do you know if you're looking at one? If you're looking at the graph, if you're looking at the equation, or if you're looking at the table? Well, number one, you know you're looking at a parabola on the graph if the curve you're looking at is a symmetrical curve that has one maximum or one minimum. Yeah, red is okay. So if it is smile-shaped, then it has a minimum, and if it is frown-shaped, then it has a maximum. So that means it looks like this. So if it has a smile, then you know that a graph like that has a minimum. Okay, it has a lowest value, this like lowest point, which is the vertex. And then if it's a frown, so if it looks like this, then it has a maximum. So its highest point is that same vertex, that little point at the top. Okay, how do you know if you're looking at it based on the equation? Well, hopefully you remember from a few slides ago that you'll know from the equation and also from the activity on Thursday if it has a squared variable term. So when we talk about a squared variable term, we're talking about basically x squared. Okay, so it only has one. It doesn't have x squared and y squared, just x squared. So it's a second degree equation. We talked about the degree being named after the highest exponent on x. Okay, table of values will tell you if it's quadratic if you calculate the second differences and find out that they're the same and that they're not zero. Okay, so they all have to be the same and they cannot all be zero. So any of these will tell you whether or not you're looking at a quadratic. These are the conditions that you need to be met. Okay, so on your own, in your notes, this is what I want you to do. I want you to go into your textbook, or you can pull out your phones and find the answer on Google, but the supply teacher is going to be walking around and just making sure that you're not doing other things on your phone that are off task. So what you're going to do is you're going to copy into your notes the definitions for these terms and put a diagram with those definitions. Okay, this is really important. In your notes, you want a diagram, super important. So these are things you're going to define. You're going to define the zeros of a parabola. You're going to define the vertex, the optimal value, and the axis of symmetry. So these four terms. So you can freeze the video here just while everybody does that. So again, you're looking in your textbook. You're going to check on Google. This is something you're going to need to have in your notes. So you're working on this independently. So that means quietly by yourself. Okay, go. Pause the video. Go ahead and do that. Okay, so now that we're back together again, I just kind of want to consolidate by looking at one graph together and breaking it down into these different terms that you've just looked at, which are all key features of a parabola, and explain the significance. So again, I'm going to have the supply teacher stop the video for a few minutes, give you maybe about 2 minutes to just do this. And so you're going to be looking at this graph, which is, you can see this is like a catapult, and it's launching a ball. And you're just going to tell me what are the zeros in this picture and what do they mean. What is the vertex and what does it mean? What's the optimal value? What does it mean? What's the axis of symmetry, etc., etc., etc. So you're going to describe each of those in turn for your notes, and then we'll take it up in a minute. So please pause the video and spend a few minutes doing this. For this, you can talk to the person next to you. Okay, go. Okay, welcome back. So what I'm going to do is I'm going to type this on here because I think it will be a little bit better. So let's talk about these zeros. Okay, so what are the zeros of this parabola? Well, number one, the zeros, another word for zeros is x-intercept. So I can say that an x-intercept, or a zero, there's one of them right here. Okay, that's the place where our graph is running into the x-axis. It's right here. So I'm going to label that with the point, with the coordinates. So the x value, it looks like it's at 14. So the coordinates are 14. And the y value is 0. I should change these brackets so they're square brackets to make them different. Okay, so that's 14, 0. That's one of the zeros. Now let's talk about where the other zero would be. You can see that the graph only intersects once. However, if, mathematically speaking, the graph could go past here, even though we know it can't because it's a catapult, but if it could, where would that zero be? Well, in order to figure that out, we have to know something about the parabola being symmetrical. So let's jump down right now and let's talk about that axis of symmetry so we can discuss symmetrical. So the axis of symmetry is the place that splits your parabola in half. So in our case, that axis of symmetry happens along this line. So let's go ahead and let's add in a line where that was. All right, so that line is going to be cutting our parabola in half right here. And you can see that that line is going through that place, which is at 1, 2, 3, 4, 5, 6. I know it's hard to see, but along point 6 right here. So that means that the equation for that line is x equals 6. So x and 6 are the only things we need in that equation because you can see like at this point where I'm pointing right now, the x value is 6. Here the x value is still 6. Here the x value is still 6. Here the x value is still 6. So all along this line, even though I'm changing the y value, it doesn't matter because the x value is always 6. So that's the equation for any vertical line. It's just x equals the number that it goes through. And that, in this case, is the axis of symmetry. Okay, so if the axis of symmetry, if the middle of the parabola, which goes through the vertex, is here at 6, and one of the x-intercepts, one of the zeros, is at 14, then the other zero needs to be the same distance away from the middle that the first zero was. So from 6 we have a space of 1, 2, 3, 4, 5, 6, 7, 8, which makes sense because the difference from 14 and 6 is 8. So that means that the other zero has to be 8 away from the middle, but on this side. So what is 8 away from 6? Well, that would be at -2. So we have another x-intercept on the other side, and it would be at -2. I'll just bold that so we can see it a little bit. Oops. See it a little bit better. There we go. So that other x-intercept would be at -2. Okay, so now let's finish talking about those x-intercepts. So what does that mean, the x-intercept? Well, obviously you can see here that this is the ball and it's going up and it's going down. The x-intercept is where the ball lands. Great. Okay, so of course, if this along here is time, or if it's horizontal distance, then there is no such thing as -2. Okay, if we put it in the catapult, then there is no location before it was launched. Okay, that would fit in the parabola, is what I mean to say. So this point kind of has no real meaning in when we're talking about significance related to the graph. Okay, so the next item on our list is the vertex. So the vertex is the place on the graph where your parabola goes from increasing to decreasing or from decreasing to increasing. It's the place where it changes direction. So it's right here at the top in this case. So that coordinate, oops, let's click down here. So the vertex, and we'll put that up here. So the coordinates right here are at 6 and it looks like 16, 14, 15, 16, yeah. Okay, so the coordinates are 6, 16. So when I talk about a vertex, I'm talking about both the x and the y, okay? You need both of those to form the vertex. What's a little bit different is just the optimal value. The optimal value is referring to part of the vertex, but not the whole thing. It just is talking about the y value, okay? So I can copy and paste this and change this to say not vertex, but rather optimal value. But instead of it being 6, 16, I'm just looking at this 16. Okay, I'm just looking for that important place. What is the highest value? What is the optimal value, as in the most? It is 16. Okay, next is the axis of symmetry. We already talked about that one, so we'll jump down to y-intercept. So the y-intercept might also be described as the initial value, or the initial height, or initial phi, or the starting amount. So that would be like it's the ball's height when it was just beginning. So that looks to me to be about 7, I think. 1, 2, 3, 4, 5, 6, 7. Hard to read, but yeah, right there, it's 7. So I'm going to plot another point. So the coordinates there would be 0, 7. That is the y-intercept. Okay, and I'll move that back over here where it should be. So the y-intercept is at this coordinate set. 0, 7, bold. Okay, great, cool. So that would be like the initial height of the ball. So in this case, that means that the ball was originally at a height of 7, say, meters or feet or centimeters, whatever unit this is in. Okay, and then the last key feature that we're being asked to describe is the direction of opening. So the direction of opening, the fancy word for that is called concavity. And in this case, the parabola is opening downward. So in other words, it's a frown. So we would say that it has a negative direction of opening, or that it opens down. So I'll just kind of tag that over here. Direction of opening, oops, it opens down. Sort of a general comment can kind of go in the middle. So that means that our ball is gaining height and then falling again. Okay, it's not like it's swinging up and down the other way. It is rising and falling. Okay, so hopefully that sort of consolidates what you did today. Now what I'm going to ask you to do is to think back of all the things that we've been asked to do today, which is identify the key features of a parabola, make connections between the quadratic equations, tables of values, and the features of their graphs, which is really what all of these slides were all about, just sort of breaking down those distinctions. So now what I'd like you to do is I'd like you to use the rest of the class time to work on your homework, and that next box is due tomorrow. Thanks so much.